This is a video lecture on 3D printing. It was created and narrated by Sean Krupa and is part of Ohio University's Boat of Knowledge in the Science Classroom project funded by the National Science Foundation. Let's start by reviewing the acronym STEM, which stands for Science, Technology, Engineering, and Mathematics. Many of you should be familiar with this. Today we're going to focus on technology, and in particular the technology of 3D printing, which is changing the way we think about designing and manufacturing our goods. Let's start by doing two interactive discussions. At this point, pause the video and read the prompt and discuss as a class. In particular, focus on the strengths and weaknesses of the manufacturing process described, and whether or not it can be improved. Resume the video when you're ready to continue. Now let's move on to discussion number 2. Here we have a different prompt. Again, pause the video and discuss as a class, this time focusing on how this situation is similar and different to the one described in discussion number 1. Resume this video when you're ready to continue. Hopefully in your discussion you touched on some of the following points. In discussion number 1, we were describing a mass production manufacturing scenario, where low cost can be achieved by making many replicas. However, it might take a long time to produce many objects. In discussion number 2, we were talking about individual, custom, or prototype style manufacturing, which has a higher cost per part but can be done much more quickly. It's this type of manufacturing that 3D printers are used for. 3D printers can be used to design and build single custom parts, and it can be done on site. In fact, most 3D printers fit on top of a desk. However, there's a high initial investment to purchase the printer. 3D printing is a type of additive manufacturing, which is building objects layer by layer. This is the opposite of machining, milling, or using a lathe, which works by removing material. There are two main types of 3D printers, extruders and laser sinterers. However, in this video lecture, we're going to focus on extruders. Extruders work with just a few simple parts: a build platform, a nozzle, a heating block, and a set of gears. Extruders work in the following way. As the gears turn, the raw material is forced through the heater block and out the nozzle, forming a fine stream. Extruders work by printing 3D objects layer by layer. Therefore, any 3D design is inserted into computer software, which slices the design into the layers so that the printer can print it. The material used in extruders are thermoplastics, which are plastics that melt at a low temperature. These include but are not limited to PLA, ABS, and PVA. To design 3D items, there are lots of free software available for you to use. 3 of the most popular are Tinkercad, SketchUp, and 3D Builder. All of these will create files in 2 standard formats, .stl and .obj. Using 3D design software, in this case Tinkercad, 3D objects can be made simply and intuitively. You can add an item to the platform and change its size and shape. Once your design is done, you load it into the interface of your 3D printer, which looks like this. However, at this point, all we can do is change the scale of the object and its position on the build platform. In this case, we're going to print a small set of chain links. But before we can print, the filament must be loaded into the extruder, and the build platform is covered in masking tape to help prevent sticking, and leveled so that it prints reliably. Now let's watch our 3D printer print our chain links. Normally this is about a 10-minute build, however we've condensed it into about 50 seconds. Notice how the printer goes back and forth like a typewriter as it adds each layer. This set of chain links uses about 20 cents worth of material. When the build is done, the build platform lowers and you simply pop your item off the platform. Here are some examples of objects that were printed using Ohio University Department of Physics and Astronomy's 3D printer. These include keychains and ghosts and cats that were used for outreach events. However, the real reason why the physics department at Ohio University has a 3D printer is to help aid and facilitate research. 3D printers allow you to make square pegs fit into round holes. For example, if you have two pieces of equipment that were never meant to work together, you can use a 3D printer to make a custom adapter or mount. Similarly, if you have a piece of equipment which they no longer make parts for, you can use the 3D printer to make these parts. Here are some 3D printing resources. Again, the design software that we mentioned that was free for you to use and access is Tinkercad, SketchUp, and 3D Builder. Also, an online archive of free designs can be found at www.thingiverse.com. In summary, 3D printing is a type of additive manufacturing. Most 3D printers are extruders and use thermoplastics. 3D printing is the easiest way to build custom, single, or prototype parts. 3D printing is still very much in its infancy, but it will only grow in popularity. Thanks for your attention. This concludes the video lecture on 3D printing.